Hello everyone. In this video, we are going to solve question number 8 of GATE 2019 physics paper. The question is related to a mathematical physics and it is: during a rotation, vectors along the axis of rotation remain unchanged. So for the rotation matrix 0, 1, 0, 0, 0, minus 1, minus 1, 0, 0, the unit vector along the axis of rotation is. So we have been given 4 options and we have been asked the unit vector along the axis of rotation given the rotation matrix and the operation which has been performed using this rotation matrix. So first of all, if we just take a 2D space, in 2D space, suppose in certain coordinate 2D coordinate system, you have some vector v0, which is v1 I cap plus v2 j cap, which is lying somewhere along, maybe along the x-axis, just suppose, and we want to rotate it by an angle theta such that it transformed to a new point in the coordinate system, 2D coordinate system, which is represented by v0 dash. Then this operation is done by using the help of the rotation matrix rv0. So rv0 acts on this original vector space and it transforms it to another vector which is represented by v0 dash. So the transformation is by angle theta. Now in 2D space, the rotation matrix is generally represented by cos theta minus sin theta, cos theta. So when this rotation matrix acts on a vector which is represented by v1 I cap, v2 2 cap, j cap, it will get the transform vector space, which is v2, which is nothing but v0 dash. Okay, and this is v0 and this is rotation matrix. So rotation matrix acts on this v0 vector and then it transforms into v0 dash. Now in this question, some of the properties of this square matrix are is, first of all, they are square matrices. Second, they are orthogonal, that is R transpose R is identity matrix, or in other words R transpose is equal to R inverse. They are orthogonal to each other. And the third property is determinant of this rotation matrix is always plus minus 1. Now coming to the question, we have been given question where we have been given a 3D rotational matrix 0, 1, 0, 0, 0, minus 1, minus 1, 0, 0. This is the 3D matrix which we have been given, and it says that it acts along the vector. During a rotation, the vectors along the axis of rotation remain unchanged. Therefore, it just says that when this rotation matrix, suppose r theta, is acting along this vector v0, then the axis of rotation remain unchanged. So we are just getting the original vector. So there is no change in the axis of rotation. So let us assume that vector along the axis of rotation is represented by x, which is because this is 3D case, so it's a column vector 3. So these are the components of this column vector A, B, C. So when this rotation matrix acts on this vector along which is lying on the axis of rotation, it is giving the original vector only. It's just transforming. It doesn't. The vectors are remaining unchanged. So this rotation matrix is just giving the original vector space. So this satisfies this equation. Therefore, we can write r theta times x is equal to x. So this is equation. So we will just write it 0 1 0 0 0 minus 1 minus 1 0 0. It acts on this vector which is lying along the axis of rotation, and this. So when we'll solve this equation matrix, then what we'll get is we'll get three equations. A is equal to B, then minus B is equal to C, and third is minus A is equal to C. So combining this, what we get is A is equal to B is equal to minus C. So let us choose that C is equal to 1, C is minus 1. Let us choose C. You can choose anything. If we choose C is equal to minus 1, then A is equal to B will be 1, because A is equal to B is equal to minus of C. Therefore, the components of this vector which lies along the axis of rotation is 1 1 minus 1. Now they have asked us in the question, then what is unit vector lied along this? So unit vector will be we'll just normalize this matrix, and this will just be given by a simple exercise where you can just find the normalization by this equation. X transpose X is equal to I. Therefore A B C just transpose of this column matrix is row matrix is equal to some identity matrix 1. It will just be 1. So A square plus B square plus C square is equal to 1. We know from equation 1 that A is equal to B is equal to minus C, so we can just replace it in equation 2 and we can just write A square plus C is minus A square is equal to 1. So 3A square is equal to 1. Therefore A is equal to 1 by root 3. So this is the normalization constant. So the matrix will be 1 by root 3 1 1 minus 1, or in vector notation we can just write it as I cap plus j cap minus k cap, because this just represents I plus j plus minus k cap. So in vector notation we can just write that this is the vector which lies along the axis of rotation, and hence unit vector along the axis of rotation is option B. Option B is the correct answer. Thank you for watching this video.